and welcome to my YouTube channel, where every episode I take a physics topic and hopefully explain it in a really simple and understandable way. Now, some episodes are just going to be fun physics facts, but most I'm going to try and tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. Today's episode is all about static electricity. Zzz. We've covered electric charge somewhat in other episodes, but I'll just remind you of the key rule that opposite charges attract and like charges repel. So two negative charges would repel each other, and a negative and a positive charge would be attracted to each other. I know, we've heard it all before, and we've also heard before that these forces get weaker the further apart they are. Makes sense, eh? And here's another refresher on the difference between conductors and insulators. It will surprise you not that conductors conduct charge and insulators don't. So an electrical conductor will allow a current to flow through it and will conduct charge easily. They're usually a metal. Whereas current can't flow through insulators like plastic and rubber. Static electricity is mainly caused by friction between insulators. So when certain insulating materials are rubbed together, electrons will be scraped off one and put on the other. This leaves the materials electrically charged, with a positive static charge on one and an equal negative static charge on the other. Which way the electrons are transferred depends on the two materials involved. But the main thing to remember is that only the electrons move, never the positive charges. So both positive and negative electrostatic charges are produced by the movement of electrons. It's just that the positive static charge is caused by the electrons moving away from the material. So the material loses electrons and therefore loses negative charge and is left with an equal positive charge. Also, static charges can occur on conductors too, it's just much less common. So here's the fun bit. As the charge builds up, so does the voltage. Buzz buzz. As the electric charge builds on an object, the potential difference between the object and the earth increases. If the voltage gets large enough, then the electrons can jump across the gap between the charged object and the earth and produce a spark. They can also jump to any earthed conductor nearby, and this is why we'll get static shocks from clothes and stuff. Now, this usually happens when the gap is pretty small. But that's not always the case, because lightning is an example of just a really big spark. Ooh, that's given me a fabulous idea for one of my fun physics fact episodes. The physics behind lightning. Well, that's it for today. Thank you for listening. I hope you enjoyed it. If you did and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I'll try to do a video for you.